Here is lesson 1.4, and the primary objective is to make sure we have an understanding of function notation and how it relates to graphs. Okay, it's important to understand here that just like the objective states, notation is the name of the game, which means you can expect to see. Well, what I should start with is what you could expect not to see, and that's brand new concepts. Okay. Rather, we're going to be discussing ways of communicating concepts we already know. Okay. So nothing new conceptually, just a matter of notation and communication. F of x is the same thing as y, and anytime we have two quantities that are equal, we can use them interchangeably without changing the meaning of an expression. For example, if I started with y equals 2x plus 4, I could substitute f of x and write that equal to 2x plus 4, and I have not changed any meaning whatsoever for that expression. If I were to evaluate f of 0, then I would plug 0 in for x, and I would simplify that expression by taking 2 times 0, which is 0, and adding 4. And I get f of 0 equals 4. Okay? Now remember, 0 here is an x value. F of x equals a y value. So what this notation states, and this is one of the strengths of function notation, is that in that one statement, it tells me that the x value of 0 is paired with the y value of 4, meaning this coordinate point, 0, 4, is a solution to that linear equation. I could do the same thing with f of negative 6. You can check my math on this, but I'm pretty darn sure that equals negative 8. And that tells us that that coordinate point is a solution to the equation y equals 2x plus 4. And if we thought about this from a graphical perspective, you would see that this line goes through that coordinate point and the point 0, 4. Over here, just to illustrate this point, that you could evaluate a variable. Okay, if I plugged in p for x, then my expression would say 2 times p plus 4. And because that's a variable, not a constant, I could not simplify that anymore. All right, so that right there is function notation. Again, we've evaluated linear functions in this unit. We're just using the slightly different notation. And again, the advantage here of this notation is that we can communicate an x value and which y value it's paired with, all in the same statement. All right. Here, once again, we're using function notation. We're using f of x equals 5x minus 10. We want to talk about finding the zeros of a function, or in other words, where does it cross the x-axis? Okay? When will y equal 0 is another way to think about that. Okay? What we need to do here, all right, and we'll illustrate the difference here down in the bottom. But for here, we need to let f of x equals 0. Okay? This is completely different on the previous slide when we evaluated at x equals 0. Okay? So I'm going to take f of x, which is the left side of the equation, put that in for 0. And I'm left with this equation that 0 equals 5x minus 10. Okay? Now this can be solved in 2 steps. I'm going to start by adding 10 and move over here to the right for the sake of space. I get 10 is equal to 5 times x, and dividing by 5, I get my solution that x must be 2 to make that true. Okay? This is what we call the 0 of the function, and that is where the x-intercept occurs. Okay? So x equals 2 is a 0. What are the axes intercepts? Okay, the x-intercept I just found. Okay, 2, 0. And once again, I found that by setting f of x equal to 0, and I solved. That's what I did on this slide. The y-intercept is 0, -10, and to find this, I would plug in 0 for x, okay? And you'll see here that that would be 5 times 0 minus 10. All right, I put 0 in for x, and I evaluate. Okay, neither one of those are really mind-blowing concepts. You just have to be very careful not to confuse the two. What you'll see from time to time is that you may be asked to find a y-intercept, and somebody will go through the work to find an x-intercept, and vice versa. So you have to be clear that when you're finding x-intercepts, that's what we did up here. Okay, you're setting the y value equal to 0, and as a result, setting the function equal to 0, and solving. Whereas the y-intercept, you just plug in 0 for x, and you simplify or evaluate. Okay? Work hard to be clear on the difference between those two things. All right, last thing I want to take, well, two things, actually. Second to last, the function g of x equals 4. Okay, I want to talk about this for a moment. That equation would be a horizontal line right at y equals 4. Okay? Now, because it's horizontal, it has a slope of 0. And if you wanted to put that to the test, you could apply our typical definition of slope and do change in y over change in x, and you'll see that it always comes out to be 0. Okay? Now, as far as the notation goes, this is just g of x equals 4, because with a slope of 0, if I put it into slope-intercept form, it would be 4 plus 0 times x. And sometimes what throws people off about this constant function, or this horizontal line, whichever way you want to think about it or call it, in this form, we don't see an x value. So sometimes if we have to do anything algebraically, whether it's solving or evaluating, it's easy to get confused because we don't have that x. This is why that x is typically not written. No matter what you put in for x, whether it's 3 or -10, the very first thing that happens is it gets multiplied by 0. So it's essentially like that term isn't even there. And because of that, it does not matter what I put in for x. You would see every single time you will get y equals 4. Okay? And graphically, if you were to pick a random point that's on that line, you would see no matter what, the y-coordinate's 4. Okay? So right here, in this part, does the function have any zeros? No, it doesn't. Okay? And right down here for x-intercepts, remember zeros and x-intercepts are the same thing. What is the x-intercept? None. It doesn't have any. Okay? It runs parallel to the x-axis, and as a result, never crosses it. The y-intercept, no surprise, is 4, just like every other y value on that graph is 4. And you can see right up here, this is the point we're talking about right there. The coordinates 0, 4. Okay? Really, this is the piece I want you to focus on because that's what I think kind of throws people off about those constant functions. It doesn't look like f of x equals mx plus b. And again, it's we just have this term written because that slope is 0. That's the big characteristic about those constant functions is that slope is 0. All right, here's the last piece. It says if f of 1 is 4 and f of -2 is -3, graph the function and find the equation. Okay? Now, I'm not, for the sake of time here, I'm not going to do either one of those things. Okay? And this gets back to what I said at the beginning. This is not conceptually a new problem. Okay? This is really 1.2 and 1.3. Okay? The only thing I want to add to this is to make sure that you understand what this information right here is saying. Because a common thing that comes up with this is students have told me in the past that, boy, I see this information and I don't know where to start. I don't even know where to go. And that's because it may not be clear that with this function notation, when we say that f of 1 is 4, that means 1, 4 is a solution point or a point that this line goes through. Okay, f of 1 equals 4, and the coordinate points 1, 4, the same thing. Okay, that is the information that is being conveyed in this function notation. Likewise, f of negative 2 equals negative 3 is stating that negative 2, negative 3 is also a point, okay, that this line that I want to find the equation for, that it goes through. Okay, so if I wanted to graph it, I'd plot those two lines and connect them with a line. And then if we followed everything that we did in 1.3, we're to find the equation that we first find the slope and, then go to point slope form, okay, yada, 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 all that stuff that we did in 1.3, all right? If that's something you still need some more work on, then the lessons in 1.3 is where you want to go. Again, the only thing I want to drive home here is this, that those two things are saying the same thing. When we have f of 1 equals 4 and f of negative 2 equals negative 3, it's giving us two coordinate points. It's just giving us those points in function notation instead of writing out the coordinate points as we've seen in the past. All right, but other than that, is once we have our 2 points, finding the equation would be absolutely no different than how we've done it throughout this unit. That's all for learning target number 4. Make note of those questions. Let's talk more in class, and that's all for 1-4.